All right, when we were graphing lines, we needed 2 points in order to graph a line, right? With a parabola, you need 3 points. Now, luckily, since it's symmetric, you can find a second point pretty easily if you know your axis of symmetry. So today we're going to focus on finding our axis of symmetry. So here is our basic form of a quadratic equation. ax squared plus bx plus c. We used those a lot last chapter. I'm going to use them even more this chapter. And it's important to remember to put them in order of descending degree. So the x squared goes first, then the x, then the one without the x. And then the numbers attached to them are just alphabetical, a, b, and c. So if we have a quadratic equation in that form, y equals ax squared plus bx plus c. Then the axis of symmetry, okay, the center line for the parabola, is a vertical line. And since it's a vertical line, it has to be x equals something. And it is always negative b over 2a. Now, yesterday when we were doing problems, there was no bx. There was no middle term. And so b would just be 0, and so we'd have x equals 0 as our axis of symmetry, which is the y-axis. So that's what we were doing yesterday. But today we're going to move our axis of symmetry a little bit. So there's a few steps to remember. This is where our axis of symmetry is. C is always the y-intercept. Because if I plug in 0 for x, my first 2 terms will essentially disappear. And I'll just get c. Because I'll have 0 here and 0 here, which gives me c for my y-intercept. And from that, I should be able to get 3 points, as long as my axis of symmetry is not on the y-axis. If it is, then we just approach it like we did yesterday. So let's look at example 1. Y equals negative 2x squared plus 12x minus 7. First thing it asks us to do is find the axis of symmetry of the graph. So remember, our axis of symmetry is x equals negative b over 2a. In this case, what is b? 12. Not the x, just the coefficient, 12. What is a? Negative 2. What do I get when I simplify that? 3. The negative 12 over negative 4 gives us positive 3. So our axis of symmetry is the vertical line x equals 3.
Wait, 12 over negative 4 equals positive?
Negative 12 over negative 4. So far, so good? Now, the second part of the question asks us to find the vertex. Now, if we think about a parabola, it's shaped like, well, this parabola is shaped like this because a is negative, right? And our axis of symmetry passes right through the middle. And our vertex is that highest point, right? Well, we already know, in this case, the x-coordinate of our vertex because it's the same as our axis of symmetry, right? This is x equals 3 here in this case. So this the coordinates of that point have to start with 3, and we just got to figure out the y value. How do you think we're going to find the y value? No. We know the x value. We need to find the y value. Plug it in. Plug the x value in. Y equals negative 2 times 3 squared plus 12 times 3 minus 7. What's negative 2 times 3 squared? What's 12 times 3?
36.
36. And what's negative 18 plus 36 minus 7?
11.
11. So the coordinates of our vertex are 3, 11. So the axis of symmetry is always going to match the x-coordinate of your vertex. If it doesn't, then you did something wrong and you're way off track.
So you don't have to actually graph this to figure that out.
No, you don't.
Okay.
But if we wanted to graph it, this would be the best first step we can come up with. So if we're going to graph this, we could start by drawing our axis of symmetry at x equals 3. That's a vertical line at x equals 3. That's our axis of symmetry. And our vertex is 3, 11. So I'm going to have to scale this a little differently. We're going to have to make the y values 2 in order to fit this on the graph. Oops. So here's the point 3, 11. So far so good? Now let's see if you remember what I said about the y-intercept. If our equation is y equals negative 2x squared plus 12x minus 7, what's our y-intercept?
1x is 0.
Uh-huh.
So.
Which is y equals?
Can you repeat the question? Mx plus
Yep.
b.
What's our y-intercept? That's for a line. What's our y-intercept? Where's it going to cross the y-axis? From this, that's the equation of a line. Mx plus b is the equation of a line. We're not graphing lines. Look back in your notes. What did I say the y-intercept was? I said it today, so if you're turning back that far, you missed it. What's that?
0c.
Not 11. That's our vertex. 0c. That's our c in this case. Remember, if I plug in 0 for x, my first term disappears, right? Because I got negative 2 times 0. Second term disappears because I got 12 times 0. C is my y-intercept. So it's going to cross my y-axis at negative 7. So here's my y-intercept. Now the really cool part is, since that line is my axis of symmetry, I know that if I have that point at 0, negative 7, I'm also going to have a point on the exact opposite side at 6, negative 7. Just the mirror image of that point. Right?
Wait. Where'd you get 5? Oh, never mind.
Yeah, you got to pay attention to the scale. Yep.
Yeah.
So here's my y-intercept at 0, negative 7. I've got the mirror image point directly opposite the axis of symmetry, right here. Now that does give me enough to draw my parabola. I could draw my curve through there. Or I could remember yesterday, remember we followed that sequence 1, 3, 5, 7, 9, 11, the sequence of odds, but we multiplied it by whatever A was. What's A today in this problem?
Negative 2.
Negative 2. So instead of going 1, 3, 5, 7, 9, we're going to multiply those by negative 2. And so we would go over 1, down 2. And then over 1, down 6.
So the difference between today and yesterday is that today the A is going to actually have a value as opposed to yesterday.
Yesterday we had some with A's had a value. It's the B that has a value today that's different, the X term in the middle. Okay, so that gives us, adding those points and just gives us a little better shape for drawing it. Make sense?
Yeah.
All right, let's do another one. Y equals 3x squared minus 6x plus 2. Let's change our graph here a little bit. Let's use this one. So the first thing we need to figure out is what our axis of symmetry is. So remember, x equals what? What's our equation for our axis of symmetry? Negative b over 2a. What's b? Negative 6. What's a? 3. So what do we get when we simplify that? Positive 1. Okay. So that tells us that our axis of symmetry is at x equals positive 1. It's a little off kilter there. Let's try to straighten this out a bit. How do we find our vertex?
Fill it in.
Plug 1 back in for x. So y equals 3 times 1 squared minus 6 times 1 plus 2.
So, I have a question. The line, it's dotted line, or it doesn't matter if it's dotted or solid?
Well, the problem is if we draw a solid line, it's going to look like it's actually part of our graph. Okay? And it's not part of our graph, it's just a mark on our graph that we're reflecting over. It's just a reference line, not an actual part of the function itself. So yes, if we check this out, we get y equals negative 1. That tells us that our vertex is at 1, negative 1, right there. Okay, looking back at the equation, what's our y-intercept? Which is, what's c in this case? 2. And then we reflect that over our axis of symmetry, we get our other point, 2, 2. All right. But if we remember our sequence for graphs is 1, 3, 5, 7, 9, what do we need to multiply those by today? 3, because that's our A. Okay. So that means as we go over 1, we're going up 3, 9, 15, 21, 27. So we see that we already have that going on here. Over 1, up 3. Then we would go over 1, up 9. That would be our next point. And we got that symmetric point on the other side of the graph. Right there. So that just gives us kind of a guideline to draw through. So we can draw our parabola through those points. Make sense? Yes, no, maybe? Okay, now I want you to notice something. The vertex here is the lowest point in the graph, right? That is the minimum value for our equation. It's the smallest y value we're going to get out of this equation. But we only have a minimum value because our parabola opens up, right? If we go back to this problem, our parabola opens down and we have a maximum value. That's the biggest y value we get out. And this has very practical applications in math and in real life. So first let's do an example where we got to find the minimum or maximum value, and then we'll use a word problem. So in example 3, they give you an equation and they want you to decide if it has a minimum or a maximum value and then determine what it is. So we have f of x equals negative 3x squared minus 12x plus 10. So first of all, we remember it has a minimum value if it opens up, a maximum value if it opens down. So does this equation have a minimum or a maximum value? Yes?
Maximum, because the negative a makes it open downwards.
Right. A negative a makes it open downwards, so we have a maximum value. Where will that maximum value occur?
Like, what side of the axis? Or
0, negative
Nope.
3.
What's the type of point called?
Oh.
Where our maximum and minimum occurs? What was this point here? Not the coordinates, but what do we call that point? The vertex. Same here. Okay, the vertex is where the maximum and minimum occurs. So all we have to do to find our maximum in this equation is to find where our vertex would be. Okay, so the first step is to find the x value. How do we find the x value?
X equals negative b over 2a.
Right, it's on the axis of symmetry, whose equation is x equals negative b over 2a. So what is b in this case? Negative 12. What's a? And what do we get when we simplify that?
Negative
2.
two.
Don't forget the 2 on the bottom. That's what gave you a 4. So we got x equals negative 2. That's the first part of our maximum. But the maximum value, they're actually asking for the output. They don't really care so much about the input. They want to know what the output is. So how are we going to find the output? Plug negative 2 in for all the x's. So f of negative 2 equals negative 3 times negative 2 squared minus 12 times negative 2 plus 10. What do we get when we simplify that right-hand side?
Wait.
Negative 12
Well, oh wait.
plus 24 plus 10.
Would we then divide?
Nope. That just means the function when negative 2 goes into it. The function value when negative 2 is the input. What do we get?
22.
What's that?
Negative 2.
22.
Wait, what?
22.
I put negative 2
Yeah.
equals 22.
Whoops.
Yep, negative 12 and 24 is positive 12 and 10 is 22.
Can't even do math.
So our maximum value is 22. There's our answer. Now, one of the simplest things we can use this for is finding a height. We could use it in our vertical motion problems. If you throw a ball up in the air, the maximum height that ball is going to reach is at the vertex of a parabola. Okay? But in example 4, they give us the equation of a suspension bridge between the towers of, or the suspension bridge in Michigan, the Mackinac Bridge. And the graph forms this equation: y equals 0.0000097x squared minus 0.37x plus 549. So they're not giving you very nice, neat numbers. And x and y are measured in feet. So y is the height above the water. X is the distance from the one cable. So maybe it'll help to put a picture up here to look at this as. Let's see here. There we go. So y is the height of the cable above the water. X is the distance from that left-hand tower. So we want to find the height of the cable above the water at the lowest point. So in other words, we're looking for a specific distance here. The distance from the lowest point of the cable to the water. Okay, which is essentially the y value there. That's what we're looking for. Right? Because this line is y equals 0. And so we're just looking for that distance there, which is whatever the y value is at the vertex. So the first step is to find our vertex. Well, we need the x coordinate first, right?
Yeah.
So we've got to find our axis of symmetry. That's our x coordinate of our vertex. So what's b?
0.37.
Negative 0.37. And what's a?
0.000097.
So what do we get when we calculate that out? What's our x value?
What? I'm just gonna say what I got. I think I got it wrong. Negative 7,628.
You did get it wrong.
Yeah, had the feels. I had the feels.
Let's see.
I just plugged it into my calculator as is.
But you got to put that denominator in parentheses. Because you got to, otherwise you're dividing and then multiplying.
Mhm.
And you forgot to put the negative out in front too. So it's actually going to be positive. What'd you get? 1,907. That about right? That about what everybody got?
Mhm.
So we're estimating here, we're going to approximately 1,907. Okay? Which should make sense if you look at the picture. Because if you look at the picture, that first tick mark there is worth 500. Okay? Which means that's 1,000. Which means that's 1,500. So we have to be somewhere between 1,500 and 2,000. Right?
Mm-hmm.
So we got our x value of 1,907. How are we going to find our y value?
Oh gosh.
Plug it in. So hopefully you're accurate with your graphing calculator. Now, if you, instead of putting in 1907 and squaring it, use the answer button on your calculator. Okay? So that 1907 should be the last answer you put in your calculator, right? So what you want to do is enter 0.000097 and then answer in parentheses. Everybody see where the answer button is on the calculator?
No.
Hit second
Oh, yep, there.
negative. Yeah, but you forgot a 7.
Mm-hmm.
You forgot a 7.
And do you need parentheses?
Yep, you don't put the answer in parentheses and then square. And then minus 0.37. And then the answer button again. And then plus 549.
Wait. Okay.
Why
Yep.
are we doing this as opposed to just...
Instead of just putting in 1907?
Mhm.
Because you get a more accurate answer when you use the number your calculator came up with. Then you're not using a rounded number. You're using a more exact number.
What did you
Is this right? I got 1,607.
I got 403.
Yeah, you all got it wrong. Let's see.
196.16.
That's much closer to what it's supposed to be. You probably have a different last answer. Yeah, you don't have 1907 in there. That's the problem. You didn't do the first calculation. You can't use the answer button if you didn't use the first calculation. Yes, that's right.
I got 1.
There you go. That's
There
what we're
you
looking
go.
for. But that's because you used 1,907. Okay, so we get approximately 196. You can only use that answer button
If there's an
if the last answer was this. Okay, if you didn't do that calculation and get this, then you can't use that answer button. Okay? So that just pulls the last answer that you use. The other thing you can do is if you've got to do some intermediate calculations, you can store that answer as a variable. So if you've got to do something else before you use this number again, you can actually use store and then put in a letter. Then you can reuse that letter. Okay. I don't know if it's the calculator. I think you're just making some mistakes on how you use it.
I went to y equals and then I did like, what did I do? I did...
All right, any questions?
No, sir.
All right.